front of me, I have two equal volumes of water, about 400 milliliters each. One of them, as you can see, is sitting on a hot plate, and the other is just at room temperature. We can check the thermometers. Here we have about 72, 73 degrees Fahrenheit, or about 22 degrees Celsius. And over here, as you can see on our hot plate, our temperature is much higher. We're right under 200, right above, so almost 210, or just about approaching 100 degrees Celsius, which is our boiling point of water. As you remember from previous weeks, we classify matter in a couple of different ways. We've got pure substances like a molecule or a compound like water, hydrogen and oxygen, H2O, rather than a mixture. And it can be in different stages or phases. In this case, we've got liquid. Those molecules are moving around a little bit. Over here, we're seeing those movements happen a lot faster. We're actually seeing that gas phase change begin here. So we're gonna let that get a little hotter. And we wanted to test out your theory that perhaps Colin's body just melted. He went into very, very hot water, extremely hot water, double the recommended temperature, more than that, for our bodies. And they didn't find anything. They didn't find any bones, they didn't find any blood, they didn't find any flesh. And we're going to be represented here by, this is just from a dog bone that my dog chewed. I believe it's beef. And here we have, this is not human flesh. We're not that kind of lab. We've got some animal fat or animal flesh to represent our proteins and fats. And then of course, I've got some leftover flip-flop material from what my puppies left after they chewed up my own flip-flops. So we're gonna test your theory. We're gonna see if the extreme heat might have been what was the cause of Colin not being able to be found, his body simply disappearing. As we've learned, mass can't be created or destroyed. So what happened to it? Did it just simply melt from a solid to a liquid? Let's find out. So we're gonna let this get just a little hotter. While we do that, we'll take our control. I've got the same mass, so we weighed these out, of the bone, the flesh, and the flip-flop material. So we'll start with the bone and put the bone in there. Bone's got a couple of different types of elements that make it up. So it is a mixture. It's got some calcium, it's got some phosphorus, phosphates, but it's also got some other items there. We're gonna add the flesh and see if it sinks or floats. If it is less dense than water, it will float. In this case, it's sunk. Do you think if it was a fattier piece, would that have floated or sunk? Do you think they have the same density? And the last thing we'll do is add my poor flip-flop. And looks like that's gonna float. So we're gonna leave this in here, set our timer. So we're starting a few minutes early here, moving over here to where our temperatures were right about where I think we found Colin's, the hot springs where we found Colin's body. And we're gonna do the same thing. We're gonna add the bone to represent very similar chemical makeup in all bones. We have our flesh again. Flesh has a couple of different molecules going on. We might want to inspect that a little later. And then finally our flip-flop material. And I'm going to speed this video up for just a second so we can give it a certain amount of time. I believe it was just a few hours between when Colin fell and when they went to retrieve the body when they had the equipment to do so, and found only the flip-flops. So based on some of your theories, go back please and look from last week. What was your experimental design? Was it pretty similar? A lot of you had some pretty similar ideas, so I kind of took the experiment protocols from your lead, from the discussion. And what was your theory? If your hypothesis was that the hot temperature simply melted, what would we expect to see happen in our beaker on the left with the same temperature compared to the one on the right? I'm going to be quiet and just zoom in, speed up the time a little bit here so that you're not sitting here watching water boil, as apologies I made you do earlier. But we'll look at these a little more closely and I'll speed it up and we'll come back in a second.